Hey, Business Calc. This is the worksheet 5.1 that was at the very end of the notes. These are the homework problems that are worked out, so utilize this as notes as well, and this should help you on the quiz. I hope everyone's doing great. I sure do miss you guys. All right, so we want to give the graph. We're given the graph f at x. Okay, so this is f at x, and we want to have f prime be this chart. So a few things that we're going to kind of utilize about this graph. I know I have -4 as a value. Um, we would probably have a max there at -3, but we don't know exactly what the value is. So we could also put -3 on here. And then this is 0. We don't really know what that point is, but we know it's a 0 here. And then I know I'm at +1. So that's where I'm going to get those values from. So remember, when we take the derivative of something, the slope can be positive, negative, 0, or it's undefined. We haven't talked about any undefined. All right, so let's talk about the region over here. So we're talking about really this region that gets all the way to here. Okay, so we happen to have a 0, which is great, but we're kind of talking about this whole region here that we're dealing with. So right there, you would have a positive slope from here, this region over, if that goes up forever. And then we could have a point of inflection, but if we look at the rest of our graph from here to here, that whole part in here has a negative slope. And then if I continue down from 1 to there, that would have that on positive slope. So I guess technically what they're looking for is you'd have positive, positive, negative, negative, and positive. And we've just filled out our F prime chart. Again, that's telling us what's going on with it. Okay, problem number 2. They told us that this is our F prime chart right here. So now we're going to work from the chart and kind of do a sketch. So we have some values that they say are important. So we have -3, we have 1, and we have 4. So if we do have a negative slope, so think about a negative slope. So this is kind of coming up like this, and whether it goes above or below, we don't know. But then this could also have, oops, I'm going the slope the wrong direction. I apologize. So we have a negative slope, which looks like this, and then it continues negative until we get to 1, and then it's going to continue upward, and whether it goes above or not. So what this shows is I have a negative slope, I have a negative slope, I have a positive slope, and I have a positive slope, which matches up to all of these. Okay. Sketch the graph of f prime of x, give the f prime chart, then sketch f at x. Okay, given the graph f prime of x, so they're saying that this is actually our derivative chart, or our graph. So we're going to try and figure out f at x. So there's 2 major spots here. We have this side, which has a positive slope, and then we have this side, which has a negative slope. Okay, and I can put 1, 3, and 5 on this line. Okay, so granted we know that over here is positive, and then it turns to negative. So what's going to happen is at this was a max that had taken place, a local maximum. That means that right here we would have had a slope equal to 0. So that's basically crossing here. So I could kind of draw something like this in. Okay. And that's a tougher one. I won't quiz on this one. This is a bigger idea, but you won't see a quiz on this. All right, so number 4. says give the roots of the following. Okay, this is where we're just going to use algebra 1 skills. So we take a look at our whole equation and we recognize that we could factor an x out, and that leaves me 2x squared plus 9x minus 5, and we're setting that equal to 0. So because of this right here that says I have x equals 0, so that means the point 0 comma 0 exists on our graph. And then we're going to want to try and factor this. Okay, so if we factor, my way, I'm going to multiply the last and the first together, so I get negative 10. Factors of negative 10 that add to 9 are positive 10 and negative 1. If I add those together, I get positive 9, so I'd have 2x squared plus 10x minus 1x minus 5. I'm going to look what I have in common here. I could factor out a 2x, and that's going to leave me x plus 5. And I could factor out a negative 1 here. That's going to leave me x plus 5. Both those signs change. So that means the factored version is x plus 5 and, x plus 5 and 2x minus 1. If I set each of those equal to 0, I'm going to get x is equal to negative 5. So negative 5, 0 is the point. And then the other one, if I added 1 divided by 2, I'm going to get x equals 1/2. So that means I get 1/2 comma 0 as well. And so those are our roots. And now we want to know where the intervals where it is increasing or decreasing for the derivative. The intervals where it's increasing or decreasing as far as the derivative goes. So we're talking about the slopes. I want positive or negative slopes. So if you were to look at this graph, I've graphed it on it. Notice this is the derivative. The derivative's taking place. So I want to, let's see, am I going to test on this? No, I'm going to go ahead and skip this one. And the reason I'm going to skip it is it's a bigger concept than I wanted to go with today. All right, so for letter A, for the following function, give the intervals where it's increasing or decreasing. Okay, so I want to go ahead and take the first derivative. So remember with the derivative, I'm going to bring this 2 down front, keep my quantity, and then I'm going to take the derivative of the inside. And so this outside 2's are really not going to do much for us, but if we look here, I could factor, and I'll bring this up here so I have something to look at. So I have x minus 4, so I get x equals 0, x equals 4, and then if I solve this one as well, that's going to give me 2x minus 4 equals 0. Add 4 divided by 2, so x is also equal to 2. So at each of these places, that means the slope would be 0. So it would be a local min or a local max. Give the max and mins as ordered pairs. Okay, again, I said that if I plug these in, so I have 0 comma something, so I'll have to plug that in. I have 4 comma something, and I have 2 comma something. So if I plug 0 back into my original equation, if I plug it in here and here, I'm going to get 0 squared minus 4 times 0. That's going to give me 0 inside, 0 squared, so at 0 comma 0, I have a max or a min. If I plug 4 into that, I'm going to get 16 minus 16 quantity squared, which is 0. And then if I plug 2 in up here, I'm going to get 4. So I'm going to get 4 minus 8, which is negative 4. And then negative 4 quantity squared is 16. So that's basically where the maximum and minimums live. So I took the derivative, found the x values, plugged those x values back into the originals, and that's going to give me my maxes and mins. Let's see what else. Those are the last two. All right, graph the following function and identify each of the following. So if I were to factor this out, I'm going to get x minus 4 and x plus 1. So that means I have a root at 4 comma 0 and at negative 1 comma 0. So we can go ahead and plot those. And we want to create our f prime chart. So the only values I need right now are -1 and 4. Okay, so this is my f prime chart that we're trying to create here. So let's go ahead and take the derivative, f prime at x. That's going to give me 2x. Remember, reduce it, minus 3. So I get 2x minus 3 is equal to 0. 2x equals 3. X equals 3 over 2. Okay, so at 3 over 2, that's 1.5, so that's about right there. That's another value. So that's going to tell me where I would have a slope equal to 0 because I took the derivative. So that means it's either a max or a min. So you have to think about what our graph is doing. So if I plugged 3 over 2 into our original, so this is going to give me 9 over 4. And I'm just going to convert that. That's going to give me 2.25. And if I multiply -3 times 3, that's -9 over 2. And so that's going to give me -4.5 and then minus 4. Okay, so if we do the arithmetic here, that's going to give me 2.25 minus 8.5. So if we just do the subtraction, notice I'm not using a calculator, so please bear with me. Okay, 0. It's going to give me 5, reduce that, 4, that's 2, and 6.25. Negative 6.25. Okay, so that's going to tell me that negative 6.25, 3 halves, so 1.5, which is 3 halves, negative 6.25. So this is what our graph would look like. Intervals where it's increasing, intervals where it's decreasing. Okay, so this is increasing over here, means its slope is positive. So from 3 over 2 to infinity, it's increasing. And then if we want to know where it's decreasing, that's over here. So that's negative infinity. Oops, come on, it's curve for me. To 3 over 2. Max min, well, we have a min, and our minimum value, you look for the y value of your vertex, is going to give you negative 6.25. Then number 8, we take a look at this. We have roots, so what I want to do is I'm going to factor out x to the third from both, so I'm left with x minus 4. So that's going to give me x to the third equals 0, so x equals 0, 0. So just so you know, this in the world of algebra would have given us a wiggle. And then if I set x minus 4 equals 0, I'd get x is equal to 4, and that would just give me a cross. Remember the difference between a wiggle and a cross. Cross goes right through. A wiggle kind of has a little something that looks like that. Okay. All right, so I get 0, and I'm going to say that's a wiggle. And then I got 4, which is a cross. Okay, if it's x to the fourth, that means that the graph looks something like this. So we're going to create a wiggle here. Here's my wiggle, and then my cross looks just like that. Notice the wiggle has a little change of direction. That means it has some sort of point of inflection. F prime chart. So the values that I want to know on here so far, I have 0 and I have 4. And so if I were to take my derivative of my original function, f prime at x, I'm going to get 4x to the third minus 12x squared. Set that equal to 0. I'm going to factor out a 4x squared. And that's going to give me a x minus 3. I set both of those equal to 0. So that's going to tell me at 3 I have a slope at 0, and at 0, because 4x squared equals 0, so that would also tell me I have a slope of 0. So 4x squared equals 0. If I set that equals 0, divide by 4 is 0, divide by 4 is 0. Square root of 0 is 0. So this is our horizontal. It's our horizontal point of inflection, okay, which is right there, which means you have a slope like right there is 0. And then at 3, we also have a horizontal line being 0, m equals 0, and m equals 0. Okay, interval where it's decreasing. Okay, oh, we haven't finished our f prime chart. So this is negative here. It goes through our point of inflection at 0, so then it stays negative here. And then we have to put a 3 here as well. At 3 to infinity would be positive, so there's positive here. I don't necessarily need the both positives there because this part of the graph isn't really changing direction at all, so I'm just going to have a positive there. The intervals where it's increasing, well, it's increasing from 3 to infinity. And intervals where it's decreasing, it's going from negative infinity to 0. Remember, 0 is my horizontal point of inflection. And then from 0 to 3, it's also decreasing. So these decreasing values here, we'll do in blue. It's decreasing here, becomes 0 at that point right there, and then it's decreasing there. And remember, right there at that point, that becomes 0. Hope that works for you. Have a great day. This will also be posted on YouTube.